A two-element circuit connected in series with an instantaneous value of current of I is equal to 4.24 sine 500 t plus 45 degree that has taken real power of 270 watt at a power factor of 0.6. Lead is. So we have to find out the resistance. Okay. So power, the real power, formula of real power is I square RMS into R. Okay. Please keep this in mind, I square RMS, where IRMS is equal to Im divided by root 2. Here in the question, it is given in the form Im sine omega t plus phi. So instead of Im, we have 4.24. Okay. So IRMS will be 4.24 divided by root 2. And in the question it is given the real power, let it be PR is equal to 270 watt. Okay. So substituting it, so 270 watt is equal to 4.24 divided by root 2 the whole square into R. Okay. And we'll see what is 4.24 divided by root 2 raised to 2, and that is divided by, okay, about R we will get 30 ohm. So 30 ohm is the answer. Okay, let's move to the next question. Consider the following circuit. Okay, I hope you all can see the circuit. Here it is a 2.2 V. V is a dependent source. Okay, this is a dependent current source that is dependent upon the voltage across, okay, the voltage across this terminal AB. Okay, and that is a current source. If you want to write down the question, please pause the video and write down the question. I am going to read the question now. If a resistance of a 40 ohm is connected between the terminal A and B, then what will be the magnitude of the current through the resistor? So the question asked here is, we have to find out what will be the current flowing through the resistance of 40 ohm which is going to be connected between these two terminals, that is AB. So for that I am going to use Thevenin's equivalent, Thevenin's theorem, and I am going to convert this whole circuit into a circuit with a one voltage source in series with a resistance. Okay, so for that please keep this in mind. This is an important thing, where when there is one dependent source and independent source, when there is dependent source and independent source, so while applying Thevenin's theorem, our RTH will be equal to VOC divided by ISC, where VOC is the open circuit voltage across the terminal and ISC is the short circuit current. Okay, and VTH will be equal to VOC itself. Okay, so this is when there is a dependent as well as an independent source. Okay. Now let's do the questions. For that I am going to find out our VOC. Okay, for finding out a VOC, I am just going to redraw the circuit over here. I'll just redraw the circuit. Okay. We'll see what we get. So 0.2 volt, not volt, it is dependent, 0.2 V. Okay, minus plus 100 watt, and this is V, and this is 10 ohm. Okay, and this is open circuited. Let this node be A, and I'm going to find out V. I'm going to find out VA. For that I'm going to use node analysis over here. No current will be flowing through this branch because it is open circuited. Okay, so we can neglect this branch and write the equation. The current flowing into the junction equal to current flowing away from the junction. Current flowing into the junction is 0.2 V equal to current flowing away from the junction is VA divided by 10. Okay, from here we get VA is equal to 2V. Okay, this is a relation between VA, the voltage across the 10 ohm, and the open circuit voltage. Okay, and now I am going to apply KVL over this loop. Okay, KVL over this loop. If I write it, we'll get V minus 100 minus VA equal to 0. Okay, so V minus 100, instead of VA I can write 2V equal to 0, and from here we get V is equal to minus 100 volt, or VOC is equal to minus 100 volt, right? And now we have to find out ISC. So to find out ISC, I am going to short circuit the terminal AB. Firstly, we will draw the circuit. So this is short circuit. Now V is equal to 0 because it is short circuit. What will happen when V is equal to 0? 0.2 into 0 will be equal to 0, and this can be neglected, and this will be equal to 10 ohm, 100 and ISC, right? And writing the equation over here, we'll write the equation over here, we'll get minus 10 into ISC plus 100 equal to 0, and ISE equal to 100 divided by 10, or 10 ampere. Okay, so VOC we got, it is equal to ISC equal to 10 ampere, VOC equal to minus 100 volt. So RTH is equal to VOC divided by ISC, which is equal to 100 divided by 10. We can take the modulus, we will get 10 ohm. So this is the RTH, and VTH is our VOC itself. Okay, VOC is minus 100 volt. I am going to redraw this particular circuit and replace that with a voltage source in series with a resistance. That is Thevenin's theorem, right? Voltage source in series with a resistance. Voltage source is VOC, that is minus 100, in series with RTH, that is 10 ohm. Okay, so this is replaced to this one, and in the question it is asked if a 40 ohm resistor is put across this terminal A and B, what current will be flowing through this resistance. Okay, now we will find out what current will be flowing through this resistance. That will be, let it be, the current across this loop be I, and write in the equation we get 100 minus 10I minus 40I equal to 0, or 100 equal to 50I, and I is equal to minus 2 ampere. Okay, this is the answer. Now let's do the next question. Okay, let's do the next question. Find V0 of the circuit shown. Okay, for that I am going to simplify the circuit first, and then we will find out V0. If you look into the circuit, these two, 6 ohm and 3 ohm, are in parallel. So I am going to find out the resultant resistance, that is 6 into 3 divided by 6 plus 3, which is equal to 2 ohm. So these two in parallel can be replaced by a 2 ohm resistance. So I am going to redraw it. It will be 4 ampere, 2 ohm, then again 6, 14, 8, 2 volt and 4. Okay, and now I am going to apply source transformation technique here, where a current source in parallel with a resistance can be replaced by a voltage source in series with a resistance. So it will become current source voltage will be equal to 4 into 2, V is equal to IR. So it will be 8 volt in series with 2 ohm. Okay, again 6, 14, 8, 2 volt, V0 and 4. Okay. And now these two 6 and 8 are in series. So 2 are in series. I can replace that with 8. And now I am taking this node. Let it be A. Okay. And the voltage on that node be VA. And writing the equation over here, we will get, let current be flowing away from the node. We will get VA plus 8 divided by 8 plus VA minus 14 divided by 8 plus VA minus 2. Actually it is 1. Okay, I'm sorry. Minus 1 divided by 4, which is equal to 0. Okay. So 2VA minus 6 divided by 8 plus VA minus 1 divided by 4 equal to 0. 2VA minus 6 plus 2VA minus 2, I am taking the LCM, okay, equal to 0. We will get, and VA equal to 2 volt. Okay. So we got VA is equal to 2 volt. And writing the equation from here and flowing from here, we will get VA minus V0 minus 1 equal to 0. Okay. So that is 2 minus V0 minus 1 equal to 0, or V0 equal to 1 volt. So that is the answer. Let's move on to the next question. Okay. Find the power delivered by the current source in watt. Okay. So in the question it is asked to find out the power delivered by the current source. Okay. So we have to find out the equivalent resistance of this whole circuit. Then only we can find it out. Okay. Whenever this kind of a delta kind of connection come, there we have to in most cases we have to use this star delta transformation. Okay. So I am going to transform this delta. This is a delta connection. So I am going to transform that into a star connection. Let it be R1, R2 and R3. And here also this is a delta connection. I am going to replace that with a star connection. Okay, same here. Okay, let it all this is, since these all are 6 ohm, so everything will be having the same resistance only. So all 3 will be R1 and here all 3 will be R2. Okay, and finding out R1 is equal to star delta transformation. The equation is 6 into 6 divided by 6 plus 6 plus 6, 36 by 18, that is 2. So everything will be replaced by 2, and here we have to see R2 equal to 3 into 3 divided by 3 plus 3 plus 3, which is equal to 9 divided by 9. So it can be 1 ohm. And now I am going to redraw the circuit. After simplification, it will be like this: 2, 2, 2, and the other part 1 is there. Okay, 1, and the next one is 1 1 and 1. Okay, so this is how it will look. And here you can see this 1 and this 1 are in series, and this 1 and this 1 are in series. So I can add up together and write it like this, and these two are in series too. So I can simplify it and write 3 2 2. Right. And now what we can do now is I'll draw it much more neatly here. Two, 2, 3, okay, and this resembles a star circle. This is a star connection or Y connection, so we are going to convert that into a delta network. Okay, and the formula will be equal to, let this be R1, R2 and R3. Okay, let this be R1 equal to 2 into 2 plus 2 into 3 plus 3 into 2, the whole divided by 3, which is equal to 4 plus 6 plus 6 divided by 3, that is 16 divided by 3. And let's see what is R2. R2 is equal to, again, 16 divided by 2, that is 8, and R3 is equal to 16 divided by 2, that is 8 ohm. Okay, so I am going to replace these all and redraw the circuit over here. Hope that is visible. Okay. Redraw the circuit over here. We'll get ampere, R1 is 16 by 3, R2 is 8, and R3 is 8, and again this one is 2, this one is 2 as well. Okay, so as you can see, these two are in parallel. 2 and 8 are in parallel. Here also 2 and 8 are in parallel. We'll get 2 into 8 divided by 2 plus 8, that is 16 divided by 10. Okay, here also after simplifying we'll get 16 divided by 10, and if I redraw the circuit, I'll get 2 ampere, 2, this one is 16 divided by 3, then 16 by 10 and 16 by 10, and that too in series. So that will be 16 by 10 plus 16 by 10, that is 32 by 10, which is in parallel with 16 by 3. Okay, so that way we will get 32 by 10 in parallel with 16 by 3. Please do that. We will get equal to 2 ohm. Okay, if I do the computation here, this paper will not be enough. So it is 2 ohm, and redrawing the circuit, the final circuit, I am going to redraw it. We'll get 2 ampere in series with this 2 ohm, and our resultant 2 ohm, and the total resistance equal to 2 plus 2, that is 4, and the power is asked here. Power is equal to I square into R. Here I is 2, the whole square into 4, that is equal to 4 into 4, that is 16 watt. Okay, this is the answer. Okay, now let's do the next question. Now in this question, find the power dissipated in the 5 ohm resistor in watt. Okay, so here is a DC source. So what happens when a capacitor is connected with a DC source? It will act as open circuit and an inductor will act as short circuit. So I am going to use that principle over here. So that is 30 resistor will be as it is, and this is 5 ohm, and this will be acting as short circuit, and the capacitor will be acting as open circuit. Okay, now we can see 10 ohm and 5 ohm are in parallel. So we'll get 10 into 5 divided by 10 plus 5, that is 50 divided by 15 or 5 divided by 15 or 10 by 3. Okay, 10 by 3, which is in series with 20 ohm. Okay, so total resistance equal to 10 by 3 plus 20, which is equal to 70 by 3. So actually this is a 30 volt in series with 70 by 3. So total current is equal to 30 divided by 70 by 3, which is equal to 9 by 7. So that is the total current. And now coming back to the question, we have to find out the power dissipated in 5 ohm. So I am going to redraw the circuit over here. 10 ohm and 5 ohm are in series, and here comes our 20 ohm, 30 volt, and we have found out that it is the total current is 9 by 7, and 9 by 7 is being divided between 10 ohm and 5 ohm. So applying current division principle, the current coming to 5 ohm resistor is 9 by 7 into opposite resistance divided by total resistance, that is equal to 6 by 7, and the current through the 5 ohm is 6 by 7, and we have to find out the power, which is equal to I square into R, that is 6 by 7 the whole square into 5, which is equal to 3.63673 watt. Okay, so this is the answer. Let's move to the next question. In the circuit given below, the value of current I2 will be. So we have to find out the value of the current I2. So yesterday while I was doing a question on similar kind of a question, whenever there is a current source in between two meshes, we use super mesh analysis. You can see that there is a current source between two meshes. So I am going to use super mesh analysis. When super mesh analysis is used, we will remove the current source and then we will write the KVL equation. Okay, so we are going to assume that this 8 ampere current source is not here, and write the super mesh, that is the whole mesh will be taken, not individual meshes. We are going to take the one mesh as a whole and write the super mesh equation. And writing the super mesh equation, I'll start from here. I2 current is flowing through it, so minus 3I2 minus I2 plus 7 minus 4I1, because 4 ohm I1 is flowing, plus 5 minus 2I1 equal to 0. Okay, taking I1 terms alone, we will get minus 4I2, and taking I2 terms alone, I1 terms alone, we will get 6I1 plus 12 equal to 0. Simplifying, we get 4I2 plus 6I1 equal to 12, or 2I2 plus 3I1 equal to 6. So let this be equation number 1, and from here we can see that I1 minus I2 equal to 18. Okay, and using these two equations we have to find out I2, right? So instead of I1 we can write 18 plus I2 and substitute that in this equation. We'll get 2I2 plus 3 into 18 plus I2 equal to 6. 2I2 plus 54 plus 3I2 equal to 6, or 5I2 equal to minus 48, and I2 is equal to minus 48 divided by 5, which is equal to minus 9.6 ampere. Okay, so that's the answer. Now let's do the next question. Now, in the following circuit, the value of open circuit voltage and the Thevenin resistance at terminal A and B are. So, we have to find out the value of open circuit voltage and Thevenin's resistance. As you can see in this figure, there are only dependent sources present in this figure. Okay, no independent sources are there. So, as there are no independent sources, the voltage across these two terminals in open circuit condition will be 0 volt. So, we got the first one part of the question, that is we have to find out the open circuit voltage, and now the second one is we have to find out the Thevenin's resistance. So, whenever there is a question like only dependent source are there, we are going to replace this thing with a 1 volt source with current IT. Okay, 1 volt source with current IT. This is applicable when only there are independent sources. No independent sources are present in the circuit, and Thevenin's equivalent is asked. We have to replace this open circuit place with 1 volt source with IT current coming from it. Okay, and then to find out RTH, we'll do 1 divided by IT. Okay, because V is equal to IR, here V is equal to 1 volt, and to find out RTH we get 1 by IT. Okay, now let's write the equations. Okay, now we know that IT current is flowing through this, and as you can see IX is flowing from here, and then it is IT. So we can conclude that IX is equal to IT, and we'll write the equation. Okay, so when we are writing the equation, and Vx is the voltage across these two places, and Vx is equal to 1 volt. Okay, we have assumed it, and I'm going to write the equation. I'm going to travel from here. So 1, I'm traveling from here. Okay, 1 minus, I'm going to write the loop equation of this one. Okay, minus, so what is the current flowing through 600 ohm? IT current is flowing here, and it is being divided to my 0.01 Vx. Okay, so the rest of the current flowing through 600 ohm, that is IT minus 0.01 Vx. Vx we know that it is 1, so I am not going to write it, into 600 minus, again coming here, this current, this IT minus 0.01 is being divided, and minus 3x is going over here, and the rest will be coming to 300 ohm, that is 300 into IT minus 0.01 minus 3ix. Okay, or we can write it as IT itself, because Ix is equal to IT. Okay, minus 900 IT equal to 0. Okay, this is the KVL equation, and I am going to simplify it by opening the bracket. Minus 600 IT plus 6 minus 300 IT plus 3 plus 900 IT minus 900 IT equal to 0. So this 2 can be cancelled, and taking IT terms only, we'll get minus 900 IT. 1 plus 6 plus 3, that is 10, right? So plus 10, and IT is equal to 10 divided by 900. We get 1 by 90. And to find out RTH is equal to 1 divided by IT, right? That is 1 divided by 1 by 90, that is equal to 90 ohm. So RTH is equal to 90 ohm. So that's it. Now let's do the next question. Okay, now let's do the next question. Find the voltmeter reading of the circuit is on. So this is the voltmeter. So we have to find out the voltage drop across the capacitor. So there are two sources, one DC source and one AC source. I am going to use the superposition principle. First of all, I am going to consider 6 volt source only. So when there is an only DC source, what happens to the capacitor? Capacitor will act as open circuited. Okay. So I am going to draw this. Okay, this is the case when it is open circuited, and in this case actually we have to find out the voltage drop across our capacitor only. So the voltage drop in this case, let it be VC dash, will be equal to 6 volt only, because whenever it is an open circuit place, or whole of the voltage will be dropping across that particular place only. So VC dash is equal to 6 volt, and now we are just going to consider our AC source only, and I'm going to draw the circuit. So now it will be a capacitor with resistance equal to 1 by j omega c. So in the equation 10 cos omega t, omega is equal to 1 here. So it will be j into 1 into c is 2. That is 0.5 divided by j, and j into j will get minus 0.5 j. So we can write minus 0.5 j, and 2 is there. Okay. Now, and it is being supplied with the AC source of 10 angle 0. Okay, 10 angle 0. Okay, now I have to find out the voltage drop across this only. Let be VC dash dash, which is equal to 10 angle 0. Voltage division principle is applied here. We 10 dash is 10 angle 0 into minus 0.5 j divided by 2 minus 0.5 j, total resistance, and I'm going to rationalize it. We'll get 10 angle 0 divided by 4.25 into 1.03 angle 7.96, and we get 2.42 angle minus 75.96, or I can write 2.42 cos omega t minus 75.96. Okay. So this is the maximum value, and to find out the total current, total voltage equal to root VDC the whole square plus VRMS the whole square. This is a formula. So V total will be equal to root VDC, that is 6 the whole square plus 2.42 divided by root 2 the whole square. VRMS is equal to VM divided by root 2. This was VM. So VRMS will be equal to 2.42 divided by root 2. That's why it came here. So the answer will be 6.24 volt. Okay. Now let's do the next question. consider the following network. Determine the potential difference between P and Q. Okay, now we have to find out the potential difference between P and Q. I am going to take these two nodes P and Q and write the node equation over here. Current flowing away from the junction is equal to current flowing into the junction. So Vp, it is connected to ground, right? Vp divided by 8 plus Vp minus 10 divided by 2 plus 2, okay, equal to 0. From here we get Vp plus 4 Vp minus 40 plus 16 equal to 0, or 5 Vp minus 24 equal to 0, or Vp is equal to 24 divided by 5 volt. And now coming to this place, I'll write the node equation, that is Vq. Okay, this is current flowing into the junction, right? So A2 equal to Vq minus 10 divided by 4 plus Vq divided by 6, and here also I am going to take the LCM. 6 Vq minus 60 plus 4 Vq divided by 24, that is 48, equal to 10 V minus 60, or 10 Vq is equal to 108, and Vq is equal to 54 divided by 5. And the question, it is asked to find out the potential difference VPQ, that is Vp minus Vq is asked here, that is 24 by 5 minus 54 by 5, or minus 30 divided by 5, which is equal to minus 6 volt. Okay, now let's do the next question. Now find the current I in the load shown by the dotted box in the below given circuit. Okay, so we have to find out the current I in this particular circuit. Current I, that is in the load shown, the current flowing to this particular thing by dotted box in the given up. So whenever these kind of questions are asked, we have to replace that with an open circuit and then find out the equivalent Thevenin's or Norton's Norton's equivalent of the rest of the circuit, and then replace, then add these element, and then find out. Okay, I'll explain through the problem. Okay, so first of all I am going to open circuit this place and find out the equivalent of the rest of the circuit. Okay, for that I am going to redraw it. So this is open circuited. Okay, now we have to find out VTH and RTH. So this is VTH. So to find out VTH is the voltage drop across this terminal. Okay, so that is equal to 50 angle 0. I'm going to use voltage division principle, that is 50 angle 0 into 1 plus j divided by 1 plus j minus j, that is 50 angle 0 into 1 plus j, or I can write, instead of 1 plus j I can write root 2 angle 45 degree, or 50 root 2 angle 45 degree. So this is the voltage drop across this particular thing, that is VTH, that is our VTH. Now we can find out ZTH. For finding out our ZTH, we have to short circuit all the voltage sources and open circuit all the current sources and look from here, and we will get VTH. Sorry, ZTH. So ZTH is equal to, these two are in parallel, right? That means minus j parallel to 1 plus j, and which is indeed in series with 1 plus j. Okay, so let's see what we'll get. R1 R2 divided by R1 plus R2 plus 1 plus j, we'll get 2 as the answer. So we are going to replace the whole circuit with the VTH in series with ZTH. Okay, so ZTH is 2 and VTH we already found out 50 root 2 angle 45 degree, and now I am going to replace that with, we actually open circuited this, right? For simplification I am going to add it back to the circuit. We'll get, was it 1? Okay, 1 and 1j, right? And to find out the current, the question was to find out the current through this particular thing. So the current is equal to 50 root 2 angle 45 degree, the whole divided by 2 plus 1 plus j. Okay, which is equal to 50 root 2 angle 45 degree divided by 3 plus j. Okay, divided by 3 plus j. Instead of 3 plus j, we can write 3.16 angle 18.43. Simplifying, we will get 22.36 angle 26.57. So this is the current flowing through our dotted region. That was in the question. Okay. Okay, now let's do the next question. In the circuit shown below, current I is equal to, so we have to find out the current through this this thing. Okay, I'm going to replace that. Okay, replace that, and to find out the current through that, I'm going to replace that with a short circuit. I'm going to find the Norton equivalent. Okay, so the current through 3 ohm, our ISC equal to 16 angle 0 into 5 divided by 8. Oh, that is equal to 10 ampere. And Rn is equal to L. To find out Rn, we will open circuit all the current sources and short circuit all the voltage sources, and look from here we see that 5 ohm and 3 ohm are in series, so Rn is equal to 8. So I can replace all these with all this up to this part only. Okay, this part will add afterwards. So we can replace all that with a current source, that is 10 angle 0, with in parallel with the Rn, that is 8. That is our Norton's theorem. And then I am going to add this 9G. Okay, now we will find out the current I. So 10 angle 0 is being divided between these two, and applying current division principle, we get 10 angle 0 into 8 divided by 8 plus 8j. So 8 minus 8j, right? That is 10 angle 0 divided by 8 into 1 minus j, or divided by 1 plus j into 1 plus j, equal to 5 plus 5G. That is 5 plus 5J ampere. So that is the answer. We'll see there. We'll do the next question. The Thevenin voltage VTH and impedance ZTH across the terminal A, B in the following network are. So we have to find out the Thevenin's voltage across this thing. Okay. So here are two current sources. One current source in parallel with the resistance, another current source in parallel with the resistance. So I am going to use a source transformation technique over here, and after doing it, I am just going to replace denote this with a box. Okay, I am not going to draw this inductor. Instead of that, I am denoting that with a box. So we will get IR, that is, this was 30 angle 90 and 40J is 40 angle 90. So we'll get 20 angle 120 angle 90, and in series with 40, that is source transformation, we have done 20 ohm. VTH is as it is, and again another 120J in series with voltage source, that is equal to 2 angle 90 into 20 angle 90, which is equal to 40 angle 180. And to find out VTH, we are going to use KVL. So VTH, I am traveling from here, VTH minus 20J into 0 because it is open circuited, minus 40 angle 180 minus 120 angle, it is 180, right, 120 angle 180 minus 40J into 0 minus 20 into 0 equal to 0. That is VTH equal to 80 angle 180, and writing that in other form, we will get 80 minus 80 volt. Okay, so the answer is minus 80 volt, and we got VTH, and now we have to find out ZTH. So to finding out ZTH, we will open circuit all the current sources and short circuit all the voltage sources, and see, open circuit all the current sources, 20J, and this is 40J, right? So we can see all of them are in series. So our RTH or our ZTH equal to 20 plus 40J plus 20J, that is equal to 20 plus 60J. Okay, so that is the answer. VTH is equal to minus 80 volt, and RTH is ZTH is equal to 20 plus 60J. Okay, now we'll do the next question. Okay, it is over. Thank you for coming by this channel, and we'll see in the next live video, and the PDF solution will be available in my Telegram group, and please do follow my Insta account or my Facebook page, and whatever it is, I will be linking down that in the description box down below. And if you want to join the Telegram study group also, you can join it, and we'll see in the next live video. Thank you. Have a nice day.